Welcome to EconTalk, part of the Library of Economics and Liberty. I'm your host, Russ Roberts of Stanford University's Hoover Institution. Our website is econtalk.org, where you can subscribe, comment on this podcast, and find links and other information related to today's conversation. You'll also find our archives, where you can listen to every episode we've ever done going back to 2006. Our email address is mail@econtalk.org. We'd love to hear from you. Today is July 30th, 2013, and my guest is Robert Pindyck, the Bank of Tokyo Mitsubishi Professor of Economics at MIT. He's the author of numerous articles in the area of the economics of climate change, industrial organization, energy, and investment under uncertainty. He's a research associate at the National Bureau of Economic Research. Bob, welcome to EconTalk.
Thanks. It's nice to be here.
Now, our topic today is climate change, a subject you've written on lately, and we'll put links up to those papers. I want to start with what you call the climate change dilemma. What is the dilemma?
Well, I think the dilemma is that we'd like to get a sense of just how far to go in terms of responding to the threat of climate change, just how far to go in terms of abatement. Should we have a very stringent abatement policy in terms of limiting how much carbon dioxide and other greenhouse gases we produce, or should we begin slowly and then perhaps later increase the extent of abatement? And the problem is it's very difficult to come up with numbers that actually tell you what the right solution is, how far to go. We know that global warming, climate change is a problem. We know that we have to do something, but we don't know quite how much we have to do at this point. And that's really the dilemma.
I want to start with a little thought experiment that you do in one of your papers, which is to say, let's suppose we know exactly what's going to happen to the temperature over the next 100 years. And we even know what the likely effects are on human well-being and in terms of financial or monetary loss. But we still have a challenge, which is how do we deal with costs that come 100 years from now or benefits that come 100 years from now relative to today? And that gets into a somewhat esoteric concept that I want to dive into, which is the idea of the discount rate. Talk about what the discount rate is used for in these kind of studies. Again, assuming we knew a lot of things we don't actually know with certainty, but just why is there a problem with trying to assess the costs and benefits that are way into the future?
Sure. So let's just begin with the discount rate and what it means. So, if you were going to get $1,000 and you had a choice of getting it today or being told you'll get it in a year, I would think that you'd prefer to have it today. And the reason is that if you get it today, you can invest it, maybe in a bond or something, and get a return over the year. So $1,000 a year from now or 10 years from now is worth less than $1,000 today. And that's a very basic concept. The rate at which, or the extent to which it's worth less, is determined by what we call the discount rate. In other words, to what extent do we discount money that we're going to receive a year from now relative to money that we would receive today. And one way to do that is to think about the alternative use to which we could put that money. We could invest it, and the interest rate that we could get would be a pretty good estimate of what the discount rate ought to be. So if I know that I can get 2% interest, let's say, then $1,000 a year from now should be discounted at a rate of about 2%, which means that it would be worth something on the order of $998 today.
And of course, if it's 10 years from now, it's going to be worth even less than $998. The idea being again, for people who aren't familiar with this, the idea is just that if you put $998 in the bank at 2%, it's going to grow to it's a little less than that actually, right? It's a little more, but in a year, it'll grow to something very close to 1,000, and so that's why $998 is something like $1,000 tomorrow. But $1,000 100 years from now is worth a lot less than $998. It's worth very little because of the power of compound interest.
Right, that's the problem. So we know that the impact of greenhouse gas emissions is going to happen very slowly. Most of the impact would happen after 50 years, maybe 100 years. And the problem is that if the discount rate is a large number, if it's even 3-4%, then any benefit that we're going to get by reducing emissions today is just not going to be worth very much if that benefit happens in 100 years from now. On the other hand,
the costs are now, which means that they're not discounted or discounted very little if they're in the near future.
Right. So the costs begin now. The costs actually are ongoing. You would have costs now, and you'd have costs throughout the future. Just to be clear about what we mean by the cost. So if we had an abatement policy, let's say it was a tax on carbon. So that's the simplest way to think about this. What we did is we taxed carbon emissions. That's going to impose a cost on society because it means that you'd have to, for example, perhaps buy a more fuel-efficient car that might be more expensive. You might have to insulate your home better. You might have to buy a more efficient furnace to heat your home in the winter. You'd have to take a number of steps that would reduce emissions, and that's costly. So if we decide to reduce emissions now by taxing carbon, that's imposing a cost on society this year, next year, every year. But the benefits that we're going to receive wouldn't occur for maybe 50 years or 100 years. That's the problem.
And how sensitive are those benefits to the discount rate? So, for example, you said if it were large, some might argue that 3 or 4% is not actually large. Maybe you should choose a higher one. We'll talk about that in a minute. But others argue it should be 0. We'll talk about why that is too. But just to think about it in a purely arithmetic sense, counting sense, what kind of differences are there going to be when you choose a discount rate close to 0 versus close to 4 or 5%?
Well, let me give you an example. Let's take $1,000 and let's discount it at 5% over 100 years. So if we do that, the way we would do that is just take 0.95 and raise it to the 100th power, and then multiply that by $1,000. What we're going to get is $6 roughly. So $1,000 100 years from now, discounted at 5%, is worth only about $6 today. On the other hand, if we discounted it at only 1% over the 100 years, then that $1,000 is going to be worth $366 today. Still quite a bit less, but very different from $6. So it makes a huge difference as to what the discount rate is.
In that particular case, that's a 60-fold difference. And that one assumption, or that's just one assumption going into the analysis, that adds an enormous amount of uncertainty about the value and net benefits of a climate change policy.
It's not so much uncertainty, it's disagreement. And the problem here is that economists disagree as to what the correct discount rate is. And there are some people who would argue that the correct discount rate ought to be something that we observe in financial markets, something related to the interest rates we actually see. There are other people who would argue that no, financial markets are fine for you and I making investment decisions. But when we look at something like climate change and we talk about 100 years, we're talking about 2 or 3 generations, 4 generations from now. And when we make intergenerational comparisons, it no longer is meaningful to use a market interest rate. And we have to think about something different. How do we feel about discounting the welfare of our great-grandchildren, for example? Should we discount their welfare? Even though for ourselves, if we say, look, for me, if I'm going to make an investment that's going to have a payoff only 10 years from now, for me, what is the discount rate I'd use? I might want to do something very different when it comes down to a different generation, grandchildren, great-grandchildren, and so on.
Now, some people have made the argument, quite a few actually, it's a legitimate position. I disagree with it, but I want to get it on the table first. It says, we should discount it at 0. Because any positive discount rate is saying that the benefits to me, this is one interpretation at least, that the benefits to me of some climate change abatement, climate change improvement, those should be no different for 4 generations from now. There's no reason I should count those less than any changes that accrue to me. So that in that argument, that argument goes the discount rate should be 0. And that's an ethical argument, correct?
Yeah, but we have to clarify something here. There are actually 2 different discount rates, and there's a discount rate on the actual monetary benefits of reducing emissions, the benefits that we'll receive in 1,000 years. In other words, let's suppose that by reducing emissions, I'm sorry, 100 years.
Or maybe 1,000, but yeah.
100 years. Let's suppose that by reducing emissions today, there's going to be a benefit to the average person of $1,000 of increased consumption in the future because GDP and consumption won't be reduced from climate change. So let's suppose there's going to be this $1,000 benefit. Now, there's a discount rate that we would apply to that benefit to put it in today's terms. There's a separate question, and that is, what is the utility or the value of $1,000 100 years from now? And that's very different. Think about this. 100 years from now, if we continue to have strong, reasonable economic growth, meaning the economy per capita, GDP, is going to grow at, let's say, 2% a year, it means that on average, people 100 years from now are going to be much, much better off on average than they are today. Well, what happens if you're much better off and you have a much higher income? It means that the value to you of an extra $1,000 is lower. So if you're a low-income person, you don't have much money, the value to you of $1,000 is a lot greater than it is for somebody who has, earns $1 million a year and couldn't care a whole lot one way or another about an extra $1,000. So the discount rate that we would apply to values, we call that the discount rate applied to utility, or the pure rate of time preference, simply says, look, I have a preference for time, for getting something now as opposed to a year from now, quite separate from the actual monetary value. In other words, quite separate from the opportunity cost of being able to put the money in the bank or invest it in a bond. I simply have a preference for getting something right now rather than in the future. And that discount rate, that rate of time preference, is what people talk about when they say it should be 0 for ethical reasons. It doesn't mean the discount rate on the monetary benefits on the $1,000 should be 0, because it shouldn't. It means that piece of the total discount rate should be 0. There's one last piece here that, and I hate to introduce all this technical stuff, but the total discount rate on the monetary gain, the $1,000 we're going to get in 100 years, is equal to the rate of time preference plus the product of the average rate of growth of the economy, per capita real growth rate, times something we call the index of risk aversion, which basically tells us how rapidly our value of money declines as we get richer. A good number for that might be 2, the index of risk aversion. If we say that the growth rate of the economy, real growth rate per capita, is about 2%, then 2 times 2% is 4%. So that even if the rate of time preference were 0, even if it were 0, we would still have a discount rate of 4% for the monetary benefit, the monetary gain. So we have to be a little careful here in terms of what discount rate we're talking about.
So
these ethical are. Go ahead.
Well, I was going to get back to the ethical argument. Why don't you go ahead?
So the ethical argument only applies to the rate of time preference. In other words, everybody would agree that, look, to the extent that the economy is going to be growing, to the extent that people will be richer on average 100 years from now, that's going to make the value of benefits received 100 years from now less worth less today. It's going to create a discount rate for benefits received 100 years from now, even if the rate of time preference is zero.
So even if you say, my blood's no redder than theirs, their blood's no redder than mine, I have no moral claim on consumption relative to theirs, you're saying there'd still be some reason to use a positive discount rate.
Right, and it could be a significant discount rate.
So here's an issue.
Depending on, go ahead.
So the issue that that's always bothered me about this, and by the way, that distinction, although it's a technical one, and I don't know if everyone out there followed it, and Bob, you've written on it, and people can look at it elsewhere or find it elsewhere. We'll try to find a link to something that helps lay that out a little more thoroughly. But what I find strange is that most people don't make that distinction. They just say, well, the discount rate should be zero because we're no better or worse than future generations. It's immoral to pretend or suggest or assume that we have some right that they don't have. They're not here. We should stand up for them, and their benefits and costs should be taken just as of the same value as ours. The part I've never understood about that, and this I think feeds into your breaking down the discount rate into two parts. The part I've never understood is that first of all, future generations are related to us, as you allude to in one of your recent papers. They don't just show up. They're tied to us through family and birth and affection, sometimes dislike, because we don't always get along. But most of us care about our children and grandchildren. And if we ask the thought question, do my grandchildren, do my great-great-great-grandchildren want me to ignore the fact that $1 today can grow over time? That is, if we incur costs today, if we make our economy smaller, and more importantly, if we slow the rate of growth, that means they're going to have less. They want us to take that into account. It would be absurd for us to say, well, costs and benefits are the same 5 generations from now as they are today because it's an ethical thing. We're all the same. But they very much want us to take into account the fact that incurring costs today impose costs on them.
Right. So there are two things. First of all, let's be clear that if we do this correctly and we look at the discount rate in terms of the rate at which we discount monetary benefits, not the rate at which we discount utility, it's not the rate of time preference. It's a bigger number, and everybody would agree that it's not simply the rate of time preference. When you say that many people just say the discount rate should be zero and they're not clear about what discount rate, I don't know what people you're thinking of or referring to. Certainly economists who look at these climate change issues and climate change policy, they certainly understand what we're talking about in terms of a discount rate, that there's a rate of time preference. There we might argue about whether it should be 0 or 2% or whatever, but that's different from the discount rate that we apply to monetary benefits. And when you talk about economic growth and you say, look, if we tax carbon today, maybe that would reduce growth, or maybe it would certainly impose a cost today. Certainly we have to include the rate of economic growth in terms of getting the discount rate that we apply to monetary benefits. There's no question about that. We're doing that. So it still means, however, that we're going to have some discount rate, and we can still argue about what that discount rate is. The whole business about future generations and the ethical argument and all of that only applies to the rate of time preference. And the rate of time preference is just one piece of the discount rate that we apply to future monetary benefits.
Okay, great. Now, the bottom line then of this section, we're going to move on to a different topic, but a related topic. But the bottom line here is that we're not clear what the right discount rate is, and that assumption has to enter into this conversation. And as a result, there's some uncertainty, and there's a range of estimates of the net present value of these costs and benefits that are very difficult to narrow. Is that a good summary of what we just talked about?
Yeah, I think it is. That's right. Yes.
Okay, so let's move into what are called integrated assessment models, IAMs, that you talk about in your forthcoming paper in the Journal of Economic Literature and elsewhere. What is an integrated assessment model?
So what economists have tried to do, economists and climate scientists have tried to do, is develop models that they could use to assess the effects of different kinds of policies. So, for example, let's begin with asking, suppose we do nothing about climate change. We don't do anything to reduce emissions. We don't do anything to abate emissions. What might happen over the next 100 or 150 years? And then we might ask, well, suppose instead that we have a carbon tax, maybe a carbon tax of $30 or $40 per ton of carbon dioxide. Well, what would that do? And to what extent would we then have a different outcome in 100 or 150 years? So what these people have done is they've developed models. And this work began maybe 25 years ago. And when it started, it was extremely useful because what it did is it showed how emissions accumulate in the atmosphere, how that in turn leads to higher temperatures, how that in turn creates damages, harms the economy in the future, and how that harm could be reduced by reducing emissions today. So the value of those models back 20 years ago was to lay out and show those interconnections and make them explicit, make them understandable. That was very useful. What's happened since then is many people started developing more and more of these models and making them more and more complicated, larger, more involved, and started to take them a little too seriously. So what these models do is the same thing that they used to do. They're models that say, look, if we don't do anything to reduce emissions, these are the kinds of emissions we're going to have over the next 50, 80 years. Yeah, this is what it's going to do to the atmospheric concentration of carbon dioxide. This is what the increased concentration of carbon dioxide will do to the temperature. And by the way, when I use the word temperature, I mean not just temperature itself, but other measures of climate change, such as greater weather variability, greater frequency of hurricanes, and so on. I'll just use temperature as a shorthand. So what will this greater concentration of atmospheric carbon dioxide do to temperature? And what will higher temperatures in turn do to the economy and to welfare? To what extent will it hurt us? So they build these models, and the models tend to have relationships. All models are sets of equations or relationships that say how X will affect Y and how Y will affect Z and so on. And in fact, we don't know we don't know a whole lot about these relationships, and the models, as a result, give sort of a false perception of knowledge and precision. That's really the issue that I have with them. But what the models try to do is to relate these different variables to each other and try to predict what might happen over some period of time under different scenarios for greenhouse gas emissions.
So this relates to an issue that comes up a lot on this our program, which is what Hayek called scientism, the use of what appear to be scientific techniques, language, in this case models, that give a false impression of scientific precision, as you point out. Why is it so uncertain? Where are the in that sequence that you laid out, which is carbon, temperature, human effects, dollar value, et cetera? Where is the part that's misleadingly precise?
Well, it's really the question is, what are the parts where we don't know enough or where we have limited knowledge? So let me back up and just make it clear what we do know. So where there's really no argument and almost no doubt among people who look at this seriously. What we do know is this. What we do know is that under business as usual, emissions of greenhouse gases include carbon dioxide, but other gases as well, such as methane, which is even worse than carbon dioxide in terms of its impact on climate. So we do know that if we don't do anything, the rate of emissions will grow over the coming decades. We know that because the economy is growing. We do know, there's no question about this, that as these emissions accumulate, and they will accumulate, and the total concentration of greenhouse gases in the atmosphere will grow, It's already grown to nearly double what it was before the Industrial Revolution. It will continue to grow. There's no doubt about that. The next thing there's no doubt about is that that will have an impact on the climate, on temperature, average temperatures, and on other measures of climate such as variability, possibly sea levels, and so on. There's no doubt about that. We know that increases, for example, we know that increases in the greenhouse gas concentration in the atmosphere will eventually have an impact on temperatures worldwide and will raise average temperatures worldwide. There's no doubt about that. And lastly, there's no doubt about the fact that that's not a good thing, that will have an adverse impact on human welfare. So there's no doubt about those things. We all know that.
Could I ask you just about a couple of those? Well,
sure.
Well, before I do, I'll let you finish. Go ahead. Say where the uncertainty is, since you think those are certain.
So we know those things will happen. Now, here's what we don't know. Let's suppose what happens when the concentration of greenhouse gases in the atmosphere doubles. What will that do to the temperature? Will it push the temperature up by 2 degrees Celsius, by 3 degrees Celsius, by 5 degrees Celsius? That's what we don't know. We don't know how bad it will be. It could be that the impact would be quite limited, maybe 1 or 2 degrees Celsius, and it won't happen for 50 years. It could be that the impact would be much worse than what we expect. Maybe it's 5 degrees Celsius and could happen well within 50 years. That's what we don't know. The second thing we don't know is, let's suppose the temperature goes up by 3 or 4 degrees Celsius, which is substantial. What would that do to human welfare? What would that do to the economy of the United States, of Europe, of other countries, to the world economy, if temperatures go up by 3 or 4 degrees Celsius? Would we be able to adapt? We know that higher temperatures would have an adverse effect on agriculture in many parts of the world, but might we be able to adapt to that by developing new types of grains, new strains, new types of things we could plant, maybe do agriculture in other regions? Maybe there would be more agriculture done in Canada and less in the southern part of the United States. Could we adapt? We don't know a lot about that. We think we could to some extent. We don't know how much. So likewise with health effects, we know that higher temperatures will imply greater transmission of disease, of communicable disease. Can we adapt to that? Can we find ways to respond to that to reduce the impact? Perhaps. So once again, we know that higher temperatures will have a bad effect. That's a bad thing. We don't know how bad. We don't know how much harm it will cause 50, 100, or 150 years from now. So that's the difficulty. We know it's bad. We don't know how bad.
And as you point out, 100 years it's not tomorrow. So there would be time for this adaptation to take place. Just don't know how easy or hard it would be. When we talk about adapting, we have some evidence, of course, on our ability to adapt. As you point out in one of your papers, people moved west in the United States, they had different soil, different climate. They found ways to farm in those places. We don't know, as you point out, though, whether a 5 degree or worse, conceivably, maybe it's 6 or 7, and maybe that's 150 years from now, but we don't know how easy or hard that would be in particular. What about the sea level effects, which a lot of people have some very scary scenarios about? Is there potential for adapting to those, or is that genuinely scary?
I mean, I think the answer is both. In some parts of the world, there is a potential for adaptation. The Netherlands, much of the Netherlands is below sea level. So there are potentials for adaptation. But it would be very expensive in many parts of the world and maybe infeasible. I think a country like Bangladesh would be in terrible shape if the sea level was to rise by 10 meters or something, 5 meters even. Countries like Bangladesh would have a very, very difficult time. It's not clear that they could adapt, and probably what would happen would there be at least an attempt at huge migrations of people out of Bangladesh into where? I mean, is India going to open its arms and say you're all welcome here? So that's a problem. Where do these
cultural
people go?
effects, and there's, even if they did go, there's cultural losses and changes, some for the better, some for the worse, that would result from that kind of massive migration. Again,
Right.
it would take place over a long period of time. Possibly, it's not.
Right.
You don't have to move to higher ground tomorrow, but you would find that certain increasingly parts of a country might not be habitable. So
it would affect the United States. Parts of the United States would have issues. I mean, even New York City, we saw during Hurricane Sandy flooding in New York City that we had never seen before. We know that New York City would have issues. Now, again, there are things that could be done. They're expensive, but things that could be done. Maybe not eliminate, but at least reduce the impact of the higher sea levels in places like New York.
Yeah, closing Yankee Stadium would be a net benefit, but that would only be one of the many effects.
Right.
My listeners know my listeners know I'm a Red Sox fan. You're at MIT, so I'm playing to that. What about?
I grew up in New York, so I still have fond memories. So anyway,
okay. Well, I'll invoke a lot. I'll turn on my empathy and try to not let it affect my interview. What about offsetting or other types of climate change, cyclical, secular trends that aren't related to human effects? Changes in sunspots, changes in the sun, changes in other things that are not human. So we assume that everything else the same. You use the phrase business as usual. Business as usual. Even if we did business as usual plus some reduction in carbon, is it clear that we know what the net effect on climate would be 100 years from now, not just from the fact that relationship appears to be somewhat variable and uncertain right now, but that there may be longer-term trends? We know there are such trends in Earth, in the Earth's climate. Is that an issue that anybody talks about?
No, because those other natural trends are trends that happen over time horizons like 25,000 years, not over 100 years or 200 years. So first of all, there's variability, and the weather varies enormously. You're going to have extremely hot summers. You're going to have extremely cool summers. That happens. But these sort of long run, another ice age or something like that's over many thousands of years. That's not really an issue here. The kinds of things we're talking about with climate change that's induced, climate change that's caused by human activity, namely burning carbon, that is something that would happen over the course of 100 years or 200 years or something like that. So it's something that would affect, maybe 2, 3, 4 generations from us.
So getting back on track, the bottom line, what you're saying is that given this, what I would say is we know the sign of these relationships. We know whether it's positive or negative. We might have a pretty good idea. We just don't know the magnitudes. Now, why is that so important? Because I think a lot of people would say, okay, so we don't know just how hot it'll get. We don't know just how difficult it will be for human economic activity in the face of hotter climates. But it's all bad, so we just need to put some tax on carbon.
Right. So, of course, the question is how big a tax. We'd like to know how serious the problem is in terms of translating that into the size of a tax. Do we need a tax on carbon that's on the order of $20 or $30 a ton of carbon dioxide, which would be equivalent to maybe a tax on gasoline of, say, 30 cents a gallon, not a very big tax? Or is it more like something like $200 or even more dollars per ton, which would be a much larger tax and would be equivalent to something like $3 a gallon tax on gasoline? So we'd like to know how big that tax should be. The problem that we face, one could argue, hey, look, let's just wait and see. Let's maybe not do anything right now, or maybe have a very small tax right now, and let's wait. And in 10 years or in 20 years, we'll sort of see how things are developing. And then if we see things are going the wrong way, the warming is happening faster than we thought, we can increase the tax. Here's the problem. The problem is that when these greenhouse gases build up in the atmosphere, they stay there. The rate at which they dissipate is very, very slow. So these greenhouse gases will accumulate in the atmosphere, and if we then stopped burning any carbon. I mean, we literally stopped burning carbon, period.
Which would be quite challenging potentially.
Yeah, it would be quite challenging. But let's suppose, hypothetically, you could do it. We could do it. We would still have this high concentration of greenhouse gases in the atmosphere that would continue to contribute to warming. We would continue to have warming for the following 40, 50 years, even if we stopped completely. So that's the difficulty, is that if we wait 20 years or 10 years, during those years, during those 10 or 20 years, we continue to burn carbon, we continue to increase the atmospheric concentration of greenhouse gases, that stuff stays there. And then if in 20 years we say, oh my God, we should have done more to stop this, it's too late because it's already there in the atmosphere. So that's a problem.
And is there any potential, or people, I know there's people talking about it, is there any potential for scientific, technological solutions to that large concentration that just sits there, even if we cut back to zero? And by the way, I should say, I always like to point out to people that when they say, well, we'll go back to living in caves. Of course, you're living in caves, you have to generally stay warm at night in lots of the earth, even if it got a little bit warmer, so you can be burning wood, and wood's got a lot of carbon in it. So this thought experiment's a very primitive one. But the question is there any technological possibility that those concentrations could be reduced through some human intervention?
Right. So there's something called geoengineering. And what geoengineering means is we engineer the earth. We make some changes to our earthly environment. And there are a number of things that have been proposed. The one that has received the most attention, that seems the most likely to actually work, although it has its own issues, is seeding the atmosphere with sulfur particles. And the way to think about this is to remember what happened when Mount Pinatubo erupted some 10 years ago or so. Maybe it was more. I forgot the date. But when Mount Pinatubo erupted, it spewed huge amounts of sulfur into the atmosphere. That's what a volcano does. And the result of that is that global temperatures dropped by 0.5 to 1 degree Celsius for several months until finally the sulfur in the atmosphere dissipated. So the idea would be to do a Mount Pinatubo for the entire planet. What we would do is we would seed the entire atmosphere, you'd even go up higher into the stratosphere, with sulfur particles. And those sulfur particles would reflect sunlight. And by reflecting sunlight, we'd absorb less sunlight. It would have a cooling effect. It would counteract, to some extent, the effect of the greenhouse gas concentration. So this has been discussed as an alternative. The idea is, look, if we don't do anything else, if we're unable to have an international agreement whereby we tax carbon or otherwise limit greenhouse gas emissions, if we simply can't make it happen, and we find out that in 40 or 50 years, good grief, the temperature is rising rapidly and we're in big trouble, what could we do? One possibility is to use this form of geoengineering, which is to seed the atmosphere with sulfur particles. Now, this is not risk-free. This has issues, but that's what has been talked about. That's the main idea behind geoengineering as an alternative. It's an alternative in the sense that, look, if everything else fails, this is what we might do.
Any prognosis on that as a possibility?
Well, I mean, there's two issues. The big issue is, does it have any negative effects? And unfortunately it does. And the negative effect is that sulfur in the atmosphere eventually comes down in the form of sulfuric acid. So what it would do is eventually, gradually acidify the oceans and also lakes and rivers and so on. Now, then the question is, how bad is that? How bad a thing would that be? I mean, the oceans have a lot of water in them. You could dump a lot of sulfuric acid before the level in the ocean becomes noticeable. but what would it do? And you'd have to keep seeding the atmosphere. It isn't that you do it once and then you're finished. Everything's fine now. You'd have to keep doing it because the sulfur particles will eventually fall down. They'll come down in the form of rain. So you have to keep doing this every year or every couple of years or every few years. You have to keep reseeding the atmosphere with sulfur particles. And that means that there's going to be an ongoing, continuing rainfall into bodies of water that is acidic, that has sulfuric acid. Now, we don't know very much about what that would do. What would it do to fish, for example? What would it do to the entire ecosystems that exist in the oceans? So we don't know what would happen, and that's why everybody hasn't jumped up and said, "Hey, no problem with global warming. All we have to do is spray sulfur into the atmosphere
or detonate some volcanoes for."
Well, yeah, I mean, it can't detonate volcanoes, but this idea of spreading sulfur into the atmosphere. So, it's something that's out there. It's something that we may end up having to try if things get bad. Who knows?
So, based on, given what you've said, it seems, and I'm not sure, I'm not quite as confident as you are about the level of certainty about all the steps, but what we do agree on, and certainly is the ambiguity about the magnitude. So isn't the lesson there, wouldn't the lesson be then, the implication be that, well, there's a potential for catastrophe, a black swan of really awful possibility, 10 degrees, huge impacts on human well-being, massive costs in the next 50 to 150 years. Isn't the prudent path then to put on that $3 a gallon gas tax, which is not so horrifying? In fact, I think for the United States, it would be less than the tax in some parts of Europe. What's the big deal? Isn't that the natural? Shouldn't we be cautious, prudent, and follow a path like that? Let's worry about the worst case scenario and be prepared.
Well, I think that's a good argument, and I think that's an argument that a lot of people make, and I'm somewhat sympathetic to it. Look. First of all, we're not talking about a black swan. A black swan happens once every, 10,000 years. We're talking about something that could happen with maybe probability 5%. Well, that's a small probability, but if you knew, huh?
Yeah, it's not the same as.
No, it's not the same. I mean, it's significant. It's still very unlikely. It's still a very small chance, but it's large enough that you'd want to worry about it. I mean, I don't think you'd go up in an airplane if you thought there was a 1% chance that the plane might crash. So, that's why we spend a lot of money taking all kinds of precautions to make sure that air travel is safe. Very, very costly to make air travel safe. But we do it because we don't want to get into those catastrophic situations where a plane crashes. So I think there's a very good argument for that. And, at this point, we know that there is this possibility of a catastrophic outcome. It's unlikely. It might be, low probability, but if it happens, it's going to be pretty bad. And as you said, look, you go anywhere in Europe and you pay the equivalent of $8 or $9 a gallon for gas. Here in the United States, gas is very cheap relative to Europe, so it's not such a big deal. It's certainly something that people could live with.
Well, part of the reason it's not such a big deal is that Europe's a smaller place. So it would change. It would have some very potentially large effects on the United States. So let's turn to that issue, which is the cost side. We've talked about the uncertainty about the benefits. What kind of assumptions are made when we're trying to assess the costs of a $3 a gallon gas tax or a more serious tax on carbon across the board? How would it change economic life here?
Well, I think one way to think about that is to remember what happened starting in the early 1970s, 1974, when there was a sharp increase in oil prices. So the United States had always enjoyed very low, very, very low energy prices, oil and other fuels as well, until about 1973, during the Yom Kippur War between Syria, Egypt, and Israel. And the Arab members of OPEC at that time tried to embargo the United States. Now, they couldn't actually embargo the United States, but what they did do is reduce their production and their exports of oil. And the result is that the price of oil in the United States and the price of gasoline in the United States jumped. It jumped quite a bit. It more than tripled at the time. And it contributed to inflation, and it also damaged economic growth to a certain extent. Maybe for a year or two, it cut 0.5% off the growth rate. We had another oil shock back in 1980 to 81. You might remember that was the time of the Iranian Revolution. Of 1979 is when the Iranian Revolution began, and then the Iran-Iraq War, which started around 1980. And what the Iran-Iraq War did is to greatly reduce oil production and exports from both Iran and Iraq, and the result was another sharp rise in oil prices. So oil prices jumped, again, tripled in the space of a couple of years. That had an impact on inflation. It was a contributor to the high inflation rates of the early 1980s. In 1980, 81, 82, we had a double-digit inflation in this country, 11, 12% inflation. And it also had an adverse effect on economic growth. So you could ask what would happen in the United States if today we doubled the price of oil, let's say, through a carbon tax. Now, nobody's talking about a tax that big that would double the price of oil, but you could still ask what would happen if we did. And there are a couple of big differences from 1982 or the 1970s that would make the impact much smaller. One big difference is that oil and energy, for that matter, is a much smaller part of our economy than it was back in the 70s and early 1980s. This country, as well as other developed countries like Europe and Japan, are much less dependent on energy than they used to be. We are much less, we say, energy intensive. The energy intensity, the amount of energy we use per dollar of GDP, is much lower today than it was 20 or 30 years ago. And that means that a sharp increase in the price of oil or energy in general would not have as big an impact and would not contribute much to inflation. In fact, in 2008, 2007, 2008, we did have a sharp increase in the price of oil. The price of oil jumped from about $60 a barrel in early 2007 to $140 a barrel by November of 2008. It was a huge increase. That had almost no impact whatsoever on the rate of inflation. We've had very low inflation in the United States and in Europe. It had almost no impact at all. And it had very little impact, some, but very little on economic growth. So I think the bottom line here is that, look, it's a cost. If you were going to go out and buy gasoline, you'd rather pay, $4 a gallon than you would $5 a gallon or $7 a gallon, of course. But it's unlikely that something like that would have a major impact, a major negative impact on growth or inflation. It's something that I think that we would easily absorb, especially if it happens slowly. No one's proposing, suddenly imposing a $3 tax on gasoline. Nobody would do that. We would do it slowly so there'd be more time for adaptation. People would have time to gradually, when they bought a new car, it might be a smaller car, a more fuel-efficient car, and so on.
So I'm going to challenge this prudent argument about doing something rather than nothing in a minute, but I want to add one more factor to this measurement of costs and benefits. I'm not an expert in the area, but when I looked at your estimates, your discussion of the estimates of the costs and benefits, it seems to me that most of them are dealing with monetary effects. That is, the fact that it may be harder to farm. It might, in some places, easier to farm, but other places harder. There might be losses in well-being because we have to spend more money, say, to keep cooler, to be comfortable. But do any of these integrated assessment models, these attempts to do a full picture of the costs and benefits, do they look at loss of biodiversity, the aesthetics or complicated effects of species loss potentially because of habitat destruction, because of climate change?
No, those are additional losses that the models don't even include.
Right. I just want to get that on the table because I think that's again, it's obviously an enormous area of uncertainty. Environmental economists have tried to use various clever ways of assessing the value that people place on biodiversity, your willingness to pay to keep the Grand Canyon preserved or pristine. And there's many problems with these methodologies. We're not going to get into them, but obviously it's another area where there's presumably a cost, very hard to measure with any precision.
Right, and those costs aren't even included when people talk about the impact of climate change. There are two kinds of costs that you can consider, that are considered. One is what we call direct economic costs. So those are, for example, reductions in the production of lumber, impact on forestry, agricultural impacts, other types of production that could be impacted by higher temperatures. So those are direct monetary costs. Then there are what we call the indirect costs, which are sometimes difficult to put in monetary terms, but we try to do that. So, for example, there's the expectation that higher temperatures would lead to a greater frequency of communicable disease, more waterborne parasites, more disease of various kinds, perhaps greater rates. We know that people die when temperatures are very hot. When you have a very hot summer, people die if they don't have air conditioning, they don't have access to air conditioning. There's significant rates of death from that. So people can make projections about how many more deaths there might be on average as a result of higher temperatures. And then what people do is try to translate that into monetary terms. They try to come up with an equivalent measure of lost GDP so that they can think about this when doing cost-benefit analysis. They don't even get to the biodiversity because we don't know how to put a monetary value on that. We don't know how to deal with the loss of pristine wilderness, for example. So that isn't even included. But what people do is they try to look at the direct economic impacts and these other indirect impacts that occur through health, migration, things of that sort.
Just an aside, again, before we get to this last issue, at one point you suggest that the economic effects, the measurable parts that you've been talking about, you say they might not just be uncertain but unknowable. Why is that, and what do you mean?
We don't have the economic theory or the economic and the data. We don't have the economic theory and the data that we would need to actually estimate these with any kind of precision. And it is quite likely that we're not going to have that kind of data or that kind of, I don't know about theory, but certainly the kind of data we would need. It's unlikely we are going to have it in the next 10 or 15 or 20 years. So that's what I mean by unknowable. It's just that we may not be able to come up with good estimates of what those costs will be, what those impacts will be. That's the problem.
So let me challenge this this prudence argument that says, sometimes it's called the precautionary principle, better safe than sorry. One of the things I really like about your papers in this area is that you're writing about this first of all, you're very aware of the limitations of so-called economic science, which I appreciate. But more than that, you're asking the question, if you care about the environment, if you're a policy economist in this area, what should be your position, and how would you use economics and econometrics and our measurement tools to make that position justifiable and somewhat meaningful? I want to suggest a different approach and get your reaction, which is this. Given that these kind of changes, the precautionary approach of, we don't know exactly what a 5% chance there is of a horrible outcome. We don't know exactly how horrible the 5% chance is or the 1% chance. So it's better to be cautious and put a significant tax on now, or let it be put on slowly, but eventually would rise to a serious level. My perspective on this is that, as you say, there's certainly a lot of uncertainty about the exact magnitudes, But what I'm not uncertain about is the political implications of giving some kind of international body the power to limit global carbon emissions. So the United States acting on its own is not going to have a very significant impact. We have billions, unfortunately, billions of people who live in very low standards of living. I very much want to see their standards of living climb. I want to see growth. That growth is going to, at least in the short run means the next half century, maybe 20, 30 years, maybe longer. That growth requires carbon. I want them to grow. So to limit growth around the world via carbon abatement is it's going to require a level of international control that's, to me, extremely unattractive on political economy or what would be called public choice grounds. And so until I see the likelihood of that, the worst case scenarios coming forward, I would be extremely cautious in advocating for a serious carbon tax on prudence grounds. What's your reaction to that?
Well, first of all, let's be clear. I mean, I don't know anybody who's advocating world government. If the United States submit its sovereignty to some kind of world government that decides how much carbon we can burn and what kind of carbon tax we're going to have, nobody suggests that. What we're talking about is hopefully getting some kind of an international agreement. That's all. Not that somebody would tell us what we have to do, but we would try to negotiate something where we thought it was beneficial for the United States and for the rest of the world, and other countries did too. Look, the fact of the matter is
we haven't been very successful at that, though, right?
No, but we haven't tried very hard at that. We didn't sign the Kyoto Protocol, so we have not bought in. The governments in the sequence of governments, administrations in the United States, have not bought into this. There's a lot of resistance to doing anything about climate change. And there's still resistance. So it's a difficult situation because, sure, it's not just that the United States and Europe and Japan have to agree. They probably would agree to a carbon tax or some other kind of equivalent reduction in emissions. But you'd have to get countries like China and India to agree, and who knows if that's even possible. So that makes it difficult. And I'm actually somewhat pessimistic about the likelihood of an agreement occurring and the likelihood that we're going to do anything. I think that we should. I think that we ought to have a carbon tax. I think that it ought to become clear to people, not just economists, but to politicians and the public at large, that there is a social cost of carbon, that there's a cost to society of burning carbon that goes beyond the individual cost you pay when you buy the carbon. And I think it's very important for people to understand that. It may be a while before we figure out what the right number is, but I think it's important to get started and try to get some countries on board. And we're not going to get the whole world on board. There are going to be free riders. There are going to be countries that say, well, that's great that those United States and Europe are doing it. We're going to keep burning all the carbon we want. That's going to happen. Hopefully there won't be too many of those free riders. But I think that's what we should do. Now, what we will do is maybe a very different story, and I'm actually quite pessimistic. I don't see much happening in at least the next 5 years, but who knows? I'm pessimistic.
Well, when I look at the 50-year or 100-year horizon, and as you point out, there's a certain set of changes already baked into the atmosphere, literally, that we really don't have much to control over. And so some of the louder voices and some of the more worried people are very they invoke some serious, frightening things. If you really thought human survival was at stake, if you really thought we're talking about a massive level of misery in response to that 5% chance or 1% chance of large climate change, it would justify some pretty horrific things on the part of some nations when those international agreements aren't entered into voluntarily. And I worry about that.
I'm sorry, I don't understand what you worry about.
Well, if you really thought the world was coming to an end in 50 years, if nothing was done, and you watched as the nations of the world negotiated with each other poorly, you'd start thinking about the fact that maybe something more drastic should be done than just sitting around a negotiating table. You might impose your will on people via military force or other mechanisms. We're not talking about – the part that's fascinating about this is we're not talking about well, it's going to get a little warmer. We're going to have to adapt. We'll do a mix of adaptation. The so-called worst-case scenario, which to me justifies potentially serious action, that worst-case scenario could lead to some really horrific things if we can't agree because of the differences between us. There's a big difference between the West with its very high per capita income and the poor nations of the world, which can house billions of people. It's not there's one nation and we can't get them to go along. India and China alone are billions of people. They live very badly. I understand their unwillingness to limit their growth and to bear costs. And they would rightfully argue they should be borne by us. And it's a very interesting, make a good movie. I'm sure there's been one. I don't know if it's been any good, but it's not a pleasant scenario. It's not the equivalent of, well, there's this externality that means people are going to die a few years earlier. There may be more people going to get emphysema. This is massive, the way it's described. I don't know if it's accurate. I don't know what's really the 5% chance.
I think you're going a little overboard. So there's the worst case scenario and there's the worst case scenario. And I think you're on the worst case scenario. I don't think that when we talk about, 5% chance or even 1% chance, I don't think it's that bad. I think we're looking at something that's still catastrophic, but not that terrible. It would be something that would impose pretty big costs on the world economy, maybe reduce the effective capital stock by 10% or even 20%. That's pretty bad. But that's kind of what
that's not human extinction.
Right. We're not talking about human extinction here. Maybe another topic for another interview we could do, which is the other stuff I work on, which is catastrophes more generally. There are other potential catastrophes on the horizon that are probably are much more threatening than climate change because they may happen much sooner. Those catastrophes are things like nuclear terrorism, or for that matter, nuclear warfare, bioterrorism. Those are human-caused things, or things like megaviruses, a virus worse even than what happened in 1918 in the Spanish flu, that kills, a chunk of the population of the world. These are things that people who study those things feel that there are very reasonable probabilities of them occurring, not in 50 or 100 years, but in the next 10 or 20 years. So I think there are a lot of bad things that could happen out there. Maybe I'm a pessimist. Maybe it's my nature. But I think that we as a government have to start thinking carefully about spending money on ways of dealing with a variety of potential catastrophes that we don't even talk about. We do almost nothing at this point, very little other than intelligence, to prevent the importation of a nuclear weapon into the United States, which could happen very easily. And we don't inspect very much of what comes over in ships. It's very expensive to inspect everything carefully, so we don't do it. We don't do very much to prepare for the possibility of an uncontrolled megavirus. Funding for the Centers for Disease Control has been cut, and it never was very much to begin with. We don't do much to develop quick response strategies so that would help us if we suddenly find ourselves in a situation with an uncontrolled virus that is, just wiping out large numbers of people. There are all these other potential catastrophes that we don't worry about and we don't talk about and we don't do anything about. So I could certainly imagine that we could get serious about a variety of potential catastrophes and think about what we ought to do and how much of our GDP we should sacrifice in order to reduce those threats, not just climate change.
On that cheerful note,
I hate to put it, make everything on that downer, but I think those are real things.
My guest today has been Robert Pindyck of MIT. Bob, thanks for being part of EconTalk.
My pleasure. Thanks.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.